Hello everyone, how are you? Today we will solve another LeetCode problem. Actually, this is the first one, LeetCode 1 to sum, which is an easy one. And what we have here, they give us a list of integers like this one, and it requires from us to find the two numbers that will add up to the target. For example, here it's 9. So which two numbers we can add, we can sum together to have 9 as summation. And here the answer is index 0 and this one, which is the number 2 and number 7. So it says it's guaranteed there is only one solution within our num list, and so we don't need to worry about multiple solution or no solution at all. We are guaranteed with one solution. So I give you an example here. We have this list of nums 2, 3, 2, 6, and 4, and our target is 6. This is target, okay, is 6. And it says we need to find the two numbers that would add up to a 6. So we can think of a direct solution or brute force solution, which is find some every two numbers together, every pair, like 3 with 2, 3 with 6, 3 with 4, and we find does it add up to 6 or not. So here 3 and 2 and is 5, it's not 6, 3 and 6 is 9, it's not 6, 3 and 4 is 7, it's not 6. And we come to the second number 2 and we check for every other possible pairs, like 2 and 6 is 8, is not the answer. 2 and 4 is 6 is the answer. But if we did not get the answer from here, we will come to 6 and check with 4. This is a solution. It will definitely give us the answer, but it's not the most efficient solution, because here we need to iterate for the worst case scenario. We need to iterate through all numbers first, and within each number we need to iterate to the rest of the list. Okay, so this is a big O of n square, which is not efficient. Do you have a better solution? Yes, we have a better solution. And how we can do it, we can simply create a hash map. So let's create a hash map here, and I will explain to you how we use the hash map. So we have a hash map here, and we will map value to the index. Okay, so even with the hash map, we can think of two ways. First, we can iterate through all numbers, and we say 3 is index 0, and 2 is index 1, and 6 is index 2, and 4 is index 3. And we do a loop, and we say, okay, so 3 is our first number, and the target is 6. And what do we need for 3 to be 6? We can say target, which is 6 minus this number 3. So we need 3. So for this one to add up to a 6, we need another number which is also 3. Do we have, like, for example, here another item that's 3? If we have, you can say, okay, this number and this number, they match and they add up together to have a target as 6. So, but here the problem, so we are looking for 3. If we look in the hash map, we will find, okay, there is 3. But this 3 belongs to the same index 0. And here we cannot reuse the same number twice. We cannot use the same element twice. So this is wrong. We cannot say 3 plus itself equals 6. It cannot. For another 3 like this one, it can. But for this list, it cannot. So creating hash map from the very start, it's not working fine unless we put if statement, if index equal this index. And this is also kind of a lot of extra work that we can do better. We can do a better solution. Let me show you a better solution. Here I will empty my hash map, and here every time we iterate through our list, we come to 3 and we say, okay, our number is 3. We have 6 minus 3 equal 3. So we need another 3. So here our hash map from the beginning is empty. So we say 3 needs another 3. Do we have another 3 here? Do we visited 3 before, like from here or from here? Do we visited 3 before? No, it does not. So this is not a solution. And what we do, we put 3 here. We say its index is 0. Now we come to the second one, 2, and say, okay, 2, which is 6 minus 2, we are looking for 4. Do we visited 4 here before? We have the hash map. Do we visited 4? There isn't 4, so we insert 2 here. We say, okay, now we visited 2, which is in index 1, but we did not find solution. For the first 2 iteration, we did not find the solution. Now we come to 6 and we say, okay, 6 is minus 6. We need 0. Do we have 0 here? We don't have 0, so we put 6 here and we give it index 2. Then we come here and we say 4, and the difference is 6 minus 4. The difference is 2. Do we have 2 here? Yes, we have 2. We visited 2 before here. So the hash map is like a history map for us. Do we visited these numbers before? Yes, and we visited 2. So we say, okay, yes, we have a hash map for 2, which is at index 1. So here we retain the result, which is at index 1, and this one is index 3. Okay, let me explain it in another way. Okay, maybe I can clean up some of these screen. Okay, let me, okay, here. Let's say we have this list of numbers, and our numbers that we are looking for them are here. We guarantee there's 2 numbers will add up to a target. So one of them is here, one of them is here. It's random placement. We don't know exactly where they are, but for sure one of them is before the other. So we visit and we update our hash map. Okay, so when we hit the first number, we make the equation to find the difference, to search for the second number, okay. But here the problem here, it can only see the history. So this is the first number, okay, but we haven't visited the history of the other number, so we cannot retain the result. So we continue scanning till we hit the second number, and when we check the history, we can find the other number is here, and then we can return the result. Okay, let's go now and write our code. So simply, first we need to create our hash map. I will call it hash map. Okay, and it's empty for start, and then we need to iterate through every element, and we also need the index, because in the hash map we will store the value and the index. Okay, so we do a simple iteration for I, and it's every element, every number in our list, enumerate and enumerate. Okay, and for our nums, first we calculate the difference, and we say the difference is basically target minus the number. And if the difference we visited before in the hash map, did we visit it before? If yes, we simply retain the result, which is our answer, which is hash map of the difference, to give us the index, and then the index of the current number, which is I. If not, basically we need to update hash map to add the new number and its index to the hash map. And here we don't need to retain anything, because we are guaranteed to find one correct solution, which is we will return it from here. So basically this is our solution. Let's test it first here in Jupyter Lab. So I created a class solution and I tested here. The target is 9, so should be index 0 and index 1, and that's true. And here the target is 6, so should be index 1 and index 2. That's correct. And here the target is 6 when we have only these two numbers, so there should be index 0 and index 1. So okay, let's take our code and we go to the LeetCode and we paste our code and we submit it. And let's say, because in the LeetCode it will do many other solutions, not the many other tests, not only these few tests I did here. So yeah, it works, and runtime is great. Memory usage is also not bad, is good. And yeah, this is considered as easy problem. I hope I was clear explaining it. If you have any question, please write to me in the comment. Don't forget to like and subscribe, and thank you.